All right, so let's talk about area accumulation and how that's represented using integrals, right? So I'm more interested in thinking about kind of some of the trickier multiple choice questions that might arise when you're dealing with something like this. So it should be by now a well-known fact that if I have a function, let's say f of x, and I integrate it from A to B along this kind of x-axis, right? So assuming I drew that properly, then the integral from A to B of f of x dx will actually be the area between the two lines, x equals A and x equals B, and the x-axis and the curve itself. So this will equal the area under the curve, so to speak. And so this is known as, again, just the simple idea of what a derivative is, right? So what if, hypothetically, I were to give you a function and I just told you graphically that maybe it looks like, I should probably stop while I'm ahead. Maybe it looks like this, okay? So it might look like this, and I'm asking you specifically what the area of this curve is, right? And let's put some actual numbers on this. So I don't know, 1, 2, 3, 4. This looks like a 4. This will go from 0 over here. Maybe we'll put this at a 1, 2. Actually, yeah, let's do that. So 1, 2, 3, 4, 5, 6, 7. Okay. And I can tell you this over here. I might actually tell you that this is not just the graph of, and obviously this is a xy coordinate plane. This is not the graph of f, perhaps the graph of f prime of x, right? So if I were to tell you this, and again, 1, 2, 3, 4, 5, 6, 7, 8, different axes, so to speak. So we'll call this 8, and we'll go from there. Then my question is, what exactly can I tell you if I know that f of 0 equals a certain value? Let's say f of 0 equals 7, okay? Would you be able to figure out the value of f of 4? Okay, and that becomes one of the main questions, so to speak. Well, if you know the fundamental theorem of calculus, then you would understand that the integral from a to b of f prime of x dx actually equals f of b minus f of a. So in our particular case, what we would understand is that the integral from 0 to 4 of this f prime of x dx actually just equals f of 4 minus f of 0. Now, if we're looking for f of 4, then there's an easy thing for us to do. We can actually go through and add f of 0 to both sides. So f of 0 plus the integral from 0 to 4 of f prime of x dx just equals f of 4, just like that. Now, if you tell me for a fact that f of 0 equals 7, then I'm going to utilize that fact. I'll tell you, okay, that's pretty cool. But then, do we know what this area is? And if we're able to calculate it explicitly and find out what that area is, then this will be great. We'll be able to figure out what f of 4 is. But sometimes you will encounter some sort of tricky question, right? And you might be encouraged to find the interval on which f of 4 might exist. Like, what are some possibilities for f of 4? So let's try this out. I can do what's known as a minimum estimate, and I could also do what's known as a maximum estimate. And let's see if these actually make sense. So in this particular case, if I were to take a little box, and we'll use light blue for the kind of minimum, then I know that the area here is at least 2 times 4. I would think that the minimum area that would possibly be involved would be, 2 height and then 4 width. And this rectangle fits snugly inside the area here. And obviously it would be an underestimate because everywhere else is higher, but this would be a minimum, so to speak. So I would say, okay, 2 plus 8. And then that would equal my f of 4. So that's my minimum estimate. Okay. And in fact, I wouldn't even say it's equal to, I would say it's less than or equal to f of 4. Okay. Now, what if I switch this around? I want to know, okay, what's a good kind of maximum estimate? So going back over here, let's say I'll use orange, all right? And I go over this interval and I start estimating over here. I guess it looks like this, all the way up. And maybe I go to there, 8. Then I would understand that 8 times 4, 32, is the maximum estimate I would have for the area of this shape. Now, 32 would look like this, and I would think that this is going to be greater than or equal to f of 4. So I'd say greater than or equal to f of 4. So some people might not find this too useful, but combining these two statements together, I can at the very least tell you that f of 4 should be greater than or equal to 15 and less than or equal to 39. And so if someone were to ask you, do you think 14 would be a good estimate of f of 4? You can tell them no, because I know that the area of this curve is at least greater than 8. And since we're starting at 7, 7 plus 8 would equal 15, and therefore 14 wouldn't even meet the minimum estimate. And you can actually solve a problem like this. So just to be clear, the idea of area accumulation is just if I have an integral here or a function here, and I take the integral of it, it gives me the area underneath the curve. Over here, I've written it in a slightly different notation. Notice that I use f prime now as my graph, f prime, and this is contrasted with f of x that I did earlier, okay? And this is just, again, to give you some exposure to a different notation, but essentially what happens is if I have a starting point, so I'll rewrite this, f of a, and I were to add the integral from a to b of f prime of x dx, this right here is actually known as the displacement or the accumulation that occurs, right? Then that will end up with my terminal value, f of b. And that's how this whole process works, right? So let's stop there.